So here we are. We have our whole project, which is now in pretty good shape, let's say. We have, if we look at the test, we have a couple things already in place with the construction with different methods, the iterations over the buckets themselves, the iterations over the dictionaries, which was quite some work itself. The delete method, we want to add now maybe another method which will be empty. So we'll do that just after. And also, yeah, we have a pretty printing, which is similar to the one in dictionary. So one thing we want to do now is add empty. So we'll just add a test set here following the delete one. Emptying dict. So we'll first add the test again, and then we'll follow by writing the actual code. So I'll just maybe okay. Yeah, I might copy paste one of the dictionaries we already created, like this one. Yes. So we create a dictionary with two values, and then we want to empty it. So empty is a function that already exists in Base Julia. We'll see the documentation right after. So, but basically, we want to test that before the empty. We want to test that the length of D is equals 2, and after the length of D is supposed to be equal to 0. And then maybe, so just to check that that iteration is working for KV in D. So here we could test anything that should be false, since we're not supposed to go into the loop, not even once, because the dictionary, the hash dict is supposed to be empty. So here we could test that value is greater than 5, just in case. So if we have some residual values here, this will error. Okay. So if we now, so let's switch to the project. So if we now test, this will error because we did not define empty on our dictionary. Okay, perfect. So let's zoom out a bit. Yes, and so no method matching empty. So we'll just define it. Yeah, let's quit the test. src hash dict. So we'll add it right after delete. Base.empty of a hash dict. So we don't need the KV specifiers for types here. They're not necessary. And what we'll do is for bucket in d.buckets, so we'll empty each bucket. So that's an easy thing to do. And then we'll just reset d.number entries equals 0, and then return nothing. I'm not sure what empty is supposed to return. We'll check that first. Let's check. Let's put that back here. What's the documentation for empty? Remove all the elements from a collection. It doesn't specify what it's supposed to return. What does, if we have a dict like this, okay, result equal empty of the dict. Result is, Our result returns the dict itself. Okay, interesting. So we return D from that. Okay. So, and now we need to define the same thing for buckets. So same thing, we define delete for buckets, so we'll just add for B, which is a bucket. And the wonderful thing is that empty is also defined for instance, for an array, I think. If I have an array which is 0, 1, 4, and I empty my array. Nope. Okay. All good. So empty is defined for arrays, and the bucket is just a bunch of items, which is an array. So we'll just empty beta items, and that's it. Well, in that case, we can return nothing, I guess. We don't need to return this, which will be the items. Okay, let's switch here. Let's test the result. Okay, tests are passing, so we now have an empty method. Okay, that was fairly easy. Now the big thing we wanted to do also in this video, and we haven't done yet, is our hashtag is not really functional yet, in the sense that it does not work properly. So the basics of a hash table is it's supposed to get an item in O of 1 in constant time. Let's say average constant time. But for now we have a fixed size, so on average we'll just keep filling the array on and on. At some point we'll have more and more items per bucket, and then the time we take to get a single item will be determined by the average size of each bucket. So what's usually done in that case is the hashtag or the data underlying the hashtag are grown when we need it. And when do we need it? It's actually determined with a load factor. I'm not sure what's the load factor people usually take. So it will be, the load factor is basically what's the number of items tops I can tolerate on average per bucket. And from John's video, if I remember correctly, he took a average load factor of 3 items, I think. You'll let me know if this is otherwise. Load. No, we'll put that in bucket, I think. We don't need that anymore. So we define our bucket here. We'll just put that there, and that will be, so we'll define a global constant here, which will be load factor. I will document it since the name is not that trivial. So average number of items, so average number of items per bucket, maximum average number of items per bucket, resizing is performed when this average is reached. Okay, so what we'll basically have is inserting an item will be cost-free until we need to resize, and at the point when we need to resize our hashtag, then this is going to be an expensive operation because we'll just change the data into something bigger. Okay. So I don't think we have a resize function. We do have a resize function already in base. and it seems to have a good semantics. So resize of a vector with an integer, resize A to contain n elements. If n is smaller than the okay, okay, that does make sense. So we basically do a resize. So we'll define resize for not for the bucket. That should actually be in hashdict. So we'll define resize for the hashdict, and what it will do is perform resize on the buckets, on the vector of buckets. So it will add more buckets, and the heuristic that's usually taken is double the number of elements. So we'll basically check first, are we doing an overflow if we do this? If we don't, then well, it's fine. Okay, so base resize hashdicts. So I don't think we need to add a size here. We'll just double every time. So if resize is called, this means we are doubling the size. We'll also document this since this is not trivial. So double the size of the data underlying hashdict called when insert inserting an item goes above load factor. Alright, so we'll have this documented. So base resize of a hashdict. How are we gonna do this? So we call, let's call resize of d dot buckets, and then so we're getting first the length of d dot buckets, and we're 2L. Yeah, we can write it like this. So this is doubling the size. So we are setting the size to 2L while it was L before. Okay. For index in, so it's from L plus 1 to L. So for each of the new items we added, these are non-initialized, so we'll need to construct proper buckets. D dot buckets index equals, so what's the constructor for bucket? We'll need the KV here, because we are gonna need the types to initialize the bucket here. So KV, I don't remember what was our, oops, what did I do? Okay, no, never mind. Yes, here. I'll just open bucket in the new one. So the constructor for bucket is just giving it items. We didn't have any convenience constructor, okay. That's surprising. How did we construct our buckets in? Okay, bucket KV with an empty. Okay, yeah, sure. So we just constructed like this. Okay. Oh, yeah, no. Huh. And now, we need, because
we have a hash problem now, because we need to replace all the elements. That's why this operation is expensive. The elements are now not in the position that will now be calculated if we use hash of a key modulo of base size, because the base size, oh yeah, right, we need to why are we keeping base size again? Do we know it? Yeah, we don't really need that, do we? Okay, whatever. We'll maybe do that later. For now, we also need to d dot base size needs to be double. Okay. Yeah, we should not really keep track of this in a variable. This is fully described by the length of the buckets, I think. So for indexing this, we initialize each bucket, and then we need to iterate over the elements. So for kv d dot bucket in d, so we'll iterate over the elements, we'll delete d at k, and then we'll add dk equals v. Why are we doing this? It's basically removing all the elements, because otherwise initially we had everything in the buckets 1 to L, and what we want after that is to replace the elements where they're supposed to be with a new base size, with a new, because we're using the base size to know where we're putting the things. Otherwise, the problem we have is that we have an imbalanced hash map with everything in the first elements, and so resizing will keep everything overloaded, and that's still inefficient in anything that has a hash, and so an index falling in the first bucket. That's why. So this operation is supposed to do absolutely nothing from an external point of view. Yeah, we did track the number of entries, which makes sense. We'll delete base size afterwards. For now, I guess it's time to, it's time to test this. Let's go there and test. Okay, we're not breaking anything, that's fairly good. And then we'll add some tests to resize. Okay, so that's going to be a new one. Test set, and then sizing not affect dictionary. So ideally, if you see all the things we're doing, we're more or less testing properties more. So we should maybe do some more advanced property testing. So have a set of dictionaries, and we try some properties on these dictionaries, and they should work for any possible dictionary. But for now, we're just using some hard-coded dictionaries, let's say. Okay, so test length d equals 2 for kv in d. Let's check, for example, that all the keys are between 2 and 3. So that's first test. And then the length of values is between 0 and 2. That should be valid. And now we, after resizing D, everything should be exactly the same. Okay, let's test that. Nope. Nope. Length of D equals, so it did not delete properly something. At 115. So we have something. So resize is inserting some elements. How can it have a length of 4? Did we forget to oh, when we delete something, are we keeping track of the number of elements? We should. Okay, yeah, this is not normal. So what we could do is first maybe at info, the good old printing everything when we don't understand something. Wait, what? How can we have multiple values being? So here we have copies, which is very interesting. Where's the problem? Maybe in delete, or is it in the iteration order? Oh, did we update base size? Yes, we did. Oh, yeah, I think this is, this is already, I think we need to delete the values first, and then we can resize only. So do we need to collect the values in between? Yeah, I think we do. So we should have, at some point, I think in the Rust version there was something like flush. It would be drain, which is take all the values from the data structure, remove them from the data structure, and get back to the values, return them to me as an iterator or something. So I think in resize, we need maybe to store all the values. Yeah, that would be catastrophic from a that would be catastrophe from a performance point of view. Because we need base size for both this and that. Maybe we need a special delete. Delete first size. Yeah, maybe. So the problem here is that we have a former base size which was computed to get where is my key value located and where can I delete it. And then we have the new one to insert. So to insert a new value, and we also need the new base size in that case. So what we'll do is add. So we'll add a function delete form older, or maybe replace resize, or yeah, replace. I like replace with key for former size, which should be an int. So key so that would be new bucket. So we're trying to find here, so that's the new bucket, and that's the new index, and old index and old bucket, and this, instead of this size here, this would be former size, and that's old index. Okay, so we have a new index, a new bucket, an old index, and old bucket. We delete the old, in the old bucket, the key. It should be there. And then, since it's a replace, we don't update the number of entry, but if we found it, we also need maybe a delete return on the bucket. No, we just get the value. Key. So if we don't find it, this is returning a key error, which is fine. Or maybe we should also have a value here. Yes. So we don't need this get here. And here we just silent, we'll just not error if we don't find it in the delete, but that should not be the case. So we delete from old buckets the key, yeah, we need the value anyway. And then if we found it, so if delete was successful, reinsert it in the new bucket. No, it's not right. We're supposed to heat. Nope. I hope this is not too confusing here, because it's fairly a fairly debugging process. So this is, I guess, what lots of programmers are doing, like mumbling around and trying to find what's going on, I hope. So if found, it means we deleted it successfully, so we can now reinsert it. And to reinsert it, it's basically reinserting it in the new bucket. So new buckets at key equal value. Okay. So we replace. So replace is. Oh wait, does replace exist? Because this is, maybe we're defining a custom function here. Yes, we'll just use the same replace. It does make sense. So this would be a special signature with former size here. Yeah, maybe we should not use the base replace. So this would be our custom function that we're just using in our package internally. So it's not exported, it's not in the key signature. We just document it to indicate what it's for. Replace key value pair from former, remove or delete from its former location and re-add it to the hash date. Okay, so if found new bucket key, yes. So how are we doing? Oh no, we used it, we defined it, but we haven't used it yet. Now back to delete. Oops. Yeah, oh, sorry, back to resize. So we resize it first. This is now fine. And here instead of delete, we replace for delete with the D, the key, which is in that case K, value V, in former size, which is L. And return D. So how is that doing now? Okay, this, yeah, it works perfect. So it's now doing a no operation, let's say. We'll just maybe, so first thing is remove our print, and we should not do it excessively, but test that the d dot base size is now double. So base size equals d dot base size, so that's the first one. Initial size okay, that, yeah, oops. Yep, perfect. Before stopping the video, we'll just commit what we've done. Add empty and resize method. Note that we haven't used resize yet. We have implemented it, but we don't have the use of it, and this should be checked first in the inserting method. So when we're inserting values into the hash date, are we overloading the hash date or not? If we're overloading it, then we should resize it. So we'll do that, I guess, next time. For now, we'll just add empty with bang and resize method